Hello everyone and welcome to today's LinkedIn live session about telco business transformation with AI-powered solutions. My name is Tia Emilsson and I work as an AI and automation innovation manager here at Ericsson, and I have the pleasure to be hosting this session today. And I see that people have joined. We had a bit of a delay, sorry for that. But I would like to know from where you are joining in the world and also from what industry you are from. And as this is the second session similar to this one, I would also encourage you to give a thumbs up if you are joining for the first time. And also if you're joining for the second time, please give us a heart. So if you joined us in the previous LinkedIn live session, there we talked about the AI business potential in the telco industry. So the AI in dollar figures, basically. And what we learned in this session is that the value of AI is often indirect, but yet measurable if you apply this framework that we developed together with Arthur D. Little. So starting with the investment and prioritizing investment based on the return you get from AI is a great starting point when starting to looking at AI. However, of course, we know that there are more to AI than just this. And in this session today, we're going into the organizational transformation, the operationalization of AI, as well as the technology itself. And at Ericsson, we started this journey with applying AI to optimize networks together with SoftBank Japan in 2018. And since then, we're now deployed AI for optimization in 13 million cells across 60 commercial networks. And we, in partnership with our customers, drive the telco AI industry transformation to enable best performing networks. So today, to address these topics of the technology of AI and as well as the organizational transformation, I have two of my colleagues here. So Claudia Munyi, calling in from Malaga online. She's our global head of sales. As well as Ibrahim Eldefar, he's joining me here in the Ericsson studio in Kista. He's our global head of solution line in the cognitive network solution service area. And our goal today is to have an interactive session, just as last time. So please put your questions in the chat, and we will try to address them as we go. And we will also have a dedicated Q&A session in the end. So throughout the years working with AI, we know then that it's not just about the technology, it's not just about the value of AI, but also about the transformation and the operationalization. So turning to you, Claudia, can you tell us a bit about where the telco industry is when it comes to AI operationalization across the operations and also optimization?
Yeah, so actually we see that the majority of CSPs have AI organizations in place and are doing different kinds of things. But in general terms, and as an industry across telco, we are still to materialize AI at scale and to really operationalize it across all the end-to-end workflows. So using data from our global service deliveries across 700,000 sites, we developed a framework to benchmark the operations maturity. And it's not only about AI and data strategy, it also cuts across other dimensions such as the organizational structure, the skill sets, the governance, and of course the end-to-end processes and workflows. So based on that, we estimate that about 70% of the CSPs globally are still on the establishment phase. That is, laying down the foundational blocks for the transformation. And this is actually very much aligned with the direct research that we conducted with Arthur D. Little that we discussed in our previous session, right? So we know that with our blueprint for transformation, because we have done that across our deliveries, we can help CSPs leapfrog through this process, minimize the risk, and succeed with this transformation.
Thank you very much, Claudia. And now just referring back to my first question to you online. So I see that the majority is here for the first time, which is great. So very warm welcome to you. And also people joining from Ukraine, from Hawaii, from India, Egypt, Philippines, Pakistan, so all over the world. This is great news, I think. So, Claudia, thank you. So it sounds like there are a potential for CSPs to accelerate in this area. And I mean, it's not a straightforward journey, which we know, as the landscape is shifting very quickly. So which are the biggest changes that we see is underway in the industry?
So actually, we see that there are two transformations ongoing in parallel. Okay. One is the transformation of processes around AI. So the challenge that operators are facing these days is that 5G provides increased opportunities for monetization, but also drives complexity. So we have come to a point where it is evident for everyone that adding more people around the legacy processes is not really going to cut it in terms of the needed volume and speed of change that we need to deliver. We need to have a step change on that. And the only way to actually materialize it is to use AI as the catalyzer for this change. But AI, as I said before, is one ingredient. We need to have everything else revolving around it, all the processes, the way we work, the people, and so on. So actually, we see that when we actually successfully adopt AI and transform the process around it, we can materialize things that were not even possible before, right? So, I mean, I'm saying all these big words and promises and this and that, but let me land it with a real experience so that you understand what I mean with a step change and massive potential to realize what was not imaginably possible in the past. So imagine a situation which is very challenging for the mobile network, a stadium, right? We are all there watching our favorite football team. We want to upload those stories so that everybody can be jealous, or the Rosalia concert, I don't know. And then this puts a lot of stress on the network on the uplink. So when we use AI to actually identify how do we need to optimize the cells in a stadium, we are able to improve the uplink speed by 50% while making it possible to carry 130% more uplink traffic. So we are improving the amount of capacity that network in the stadium can handle, in addition to improving the speed. So these are the things that, the multiple possibilities that the AI algorithms can evaluate that, based on rules or human decisions, we were never able to materialize it before. So that's kind of what happens when we change the way we work around AI. But then in addition to that, we have the cloud native journey, which in sometimes comes along embracing the service management and orchestration architecture for the network automation, which in Ericsson we refer to as Ericsson Intelligent Automation Platform. So what do I mean with this? Basically, what the situation that many CSPs have today is that they have a very siloed tools landscape. So they have a bunch of tools sitting one next to the other, completely disconnected from one another, and in many cases collecting the same data several times. So you can imagine how ineffective is this, right? You need to switch from one to the other, they cannot talk to each other and so on. So when we transition to a cloud-native architecture, we have microservices and applications running on top. We have a common data lake. So basically, we go from this vertical split into a more horizontal architecture where we have the data, the applications on top, and then we have SDKs and APIs so that we can develop things in connection to those applications. So as you can imagine, this is much more effective, and it allows increasing scalability and reusing the overall application and framework and tools landscape. So this allows engineers to work smarter, not harder, right? So concluding these two things, I mean, the two transformations, the AI and the process transformation, very much underway, different levels of maturity depending on the different part in the different moments the CSPs are on their journey. And then the cloud native transformation, this is more something that we see that the front runners around the world are starting to execute on, and the rest of the market is sensing to decide, okay, should I embrace this as a more architecture or not? How do I go about it? When is the right time to move my telco workloads to an HCP and so on? So we see a lot of RFIs and this kind of processes going on as they seem to be making up their mind which way to go, right? So what are we doing in Ericsson? In Ericsson, basically, we are helping our customers to keep their oceans open. So we have our applications, and we offer them both as standalone applications and also as apps on SMO. So they can start their process transformation around AI today, and then transition to this cloud native or SMO architecture whenever they find suitable.
Yes, I mean, this flexibility that we can use when delivering our AI software will equip the CSPs to accelerate in this area. And I also see that we got a very good question from the chat, so I will actually bring it up now. It's from Christopher Isak, and he asks can you share some examples of businesses that have successfully implemented AI and the impact it had on their operations or bottom line? And I know we have another session after summer coming on this, but should we just leave it as a cliffhanger until summer, or Claudia, do you want to give a small comment?
No, I mean, one industry that clearly has implemented AI that is ahead of us, I would say, is, for instance, there have been complete industries built around that, right? Such as Uber. I mean, all the Uber and the way the fees are working and the way you adjust the pricing of the Uber or like Airbnb and so on, all that is based upon AI, right? And calculating the demand and the and the offer. And then another good example I would say is like all the social media marketing, right? All the targeting that we have, the targeting of ads and so on. This is very much the source of many algorithms that we have today, where it's things like that. They leverage stuff like knowledge graphs that we actually also use in some of our algorithms. So it's actually quite cool to see how the same technology can be used for very different applications. But as we said, more to come. Stay tuned for the third session in this series.
Exactly. Thank you, Claudia. And now I'm super curious to go into the technology aspects, Ibrahim. So maybe we can start with our reinforcement learning technique to use together with the digital twin.
Okay, so let me bring two stories actually here, coming from our real experience with operators. CSPs in Europe, they are subject to some of the strict requirements on radiated power out of antenna. A couple of years ago, one of those operators actually reached out to us and asked us for help. We would like to introduce 5G on the same band that has 4G now. But the problem is, it is already full power radiated out of the 4G antenna. Then, how can we reduce the output power from the 4G antenna, provided that we don't jeopardize the user experience or the coverage or make additional investment for 4G, such that we make room for 5G introduction? As you can imagine, this is a very complex problem for humans to solve, right? So you have a lot of parameters coming, like what kind of traffic movement is going to happen between the different layers in 4G and future 5G. What kind of impact is going to happen on handover and mobility, what will be the impact as well on coverage, etc., etc. And then if you think about a human solution for this, you have a lot of parameters to change. You have like thousands, and maybe it sometimes reaches to millions of probabilities if you consider a full network with like hundreds of thousands of cells. Then this was a time for a reinforcement learning solution. Reinforcement learning is based on learnings in the digital domain, where you have a simulated space for how the network is really behaving. That includes traffic, that includes parameters, that includes coverage, etc., etc. And then the reinforcement learning in this digital space is learning from the different trials and errors, such that it converges to a long-term goal. And this long-term goal, as I said, is we have a reduction in the output power without impacting the user experience. We have implemented that after a lot of learnings with the customer and based on the derived network data. And the implementation results were astonishing. So we managed to reduce the output power by 20% on 4G. So now we have room to introduce 5G. But while we are reducing this kind of transmitted power, we also reduced the consumed power, the energy consumption out of 4G radios by 3.4%. Not only that, we also improve the user experience in the downlink by 5% and the uplink by 30%, without adding a single site, without doing a single hardware expansion. This is the art, and this is the science of how you do reinforcement learning, and this is the art of how you implement this, and this is the kind of AI application that you get out of it. Another story, which is more recent, it actually happened last December in one of the major football tournaments worldwide. And the customer approached us days before the final match, asking us for a solution to a problem that they didn't anticipate. The problem was that the traffic is increasing in the outdoor area of the stadium, one match to the next, and you only have 1 day between each match. They don't have time to expand. They don't have time to add new infrastructure. They don't have time to add new sites. So we need to find a solution for this outdoor area of the stadium. The solution is to do a redesign for this area. But again, considering all these kind of parameters, the interactions between 4G and 5G and the user experience, and like you need to do this very, very fast because typically you have less than 24 hours to get to some sort of recommendation out of that. That was a time where you have reinforcement learning coming. Reinforcement learning agent here to improve the coverage, to improve the electrical tilting of the different antenna. We have redesigned the whole outdoor area. And this redesign of the outdoor area was such that we can accommodate more traffic, which in the final match, like match over match, actually reached more than 15% that compared to where our baseline that we started. But with this increase in the number of users, that increase in the traffic, we also improved downlink coverage, improved uplink throughput, and improved downlink throughput. So all of it was actually, even if I can tell you, Tia, I mean, like our experience with that, it was actually going sometimes against human logic. We got some recommendation that maybe engineers were not believing that much is going to solve the problem, but it did in the end. So these are two examples how we brought this digital twin into live an application for AI.
Yeah, these are two great examples and great outcomes using advanced AI technologies. And we see that digital twins is becoming more widespread in the telecom industry, and also we see a huge interest of it. And we are actually to publish a paper on Ericsson's approach to RAN digital twins very soon. So if you're interested in reading that one, I encourage you to bookmark the cognitive software page, which you can find in the description or it's in the chat. So stay tuned and have your eyes open for this paper that is soon to be published. So another hot topic is the trustworthy AI. And I know that we are doing extensive research in this area, and especially in the explainable AI area. So Ibrahim, can you explain a bit more about what we are doing there?
Absolutely. So remember when I told you about this stadium thing and where we were discussing with the customer and discussing with the engineers on what kind of recommendation that we're going to apply? And then there were recommendations coming against the human intuition of people who have spent maybe decades of optimizing networks. In order for you to explain such kind of an AI decision or an AI insight to, like in a simple human terms, sometimes it is quite difficult. Like AI is typically a black box, right? You have an input of data, and then you have an output of recommendation or insights. But what happens in between is something like, for a lot of people who are not specialists, is kind of a black magic. What we do with explainable AI right now is that we try to open this black box and make it visible how this intrinsic machine of AI algorithms are really working. So what led this AI algorithm to come with such kind of recommendation? This is something, for example, that we have as part of like we have active research on this part, and we started really to have some of this in our product in the cognitive software that can explain, for example, why this problem has happened and what is the root cause of it, and why the recommendation in the software is directing the engineers into this part. So that helps us to make this AI visible, let's say AI mechanism is visible, and also increase this trustworthiness of the solution. And when you see that, people will start to really to have more confidence in taking this AI solutions, implementing it in the network, getting the real benefits of the improvement in the bottom line and the user experience that we have talked about before.
Yeah, I think like building trust into our software is a must of going forward and also here and now. We actually have a question in the chat on our previous discussion.
Sure.
And it's about, like, let me see. Okay, now I think it's... Oh, here we go. Why is the improvement over the uplink 50% while the downlink only 5% in the example you gave?
Okay, so one thing that we noticed in the different networks is we tend, in the previous generation, I would say, on the legacy technologies, to focus more on improving user throughput and user experience in the downlink, right? So the network design, in essence, was more to make sure that the downlink experience is where you have the, let's say, the best user experience. So think about making sure that you have the video with the highest resolution. Think about having the best performance when it comes to your own online working or online education, et cetera, et cetera. So it was more like on the downlink part. But with today's shift to more of sharing and having like going live in different social media, the uplink load is much higher. But the networks, if you think about the legacy networks that have been designed maybe like 10 years ago or something, they were not really designed to optimize in the uplink. They were designed to optimize in the downlink. So these networks typically tend to be very good when it comes to downlink coverage, but when it comes to the uplink, which is a very difficult problem to solve, because for one thing, it is very hard to quantify the impact of the different neighbors and the different impact of changing one parameter to the neighbors around that. So I think this part, what we have seen in the applications, is not just like limited to this example. This is a kind of a consistent behavior that we have seen in networks right now. They are well designed in downlink. When it comes to the uplink, it's very difficult. It's not well designed for, and AI is a very good solution for that.
Good answer. And I have one question from the chat, which also relates to my next question to you. And I will read this first, and then you will hear mine as well. So we have a question from Ashar, and it's about what emerging AI technologies or advancement do you foresee playing a significant role in shaping the future of network optimization? And my question to you is about generative AI and large language models, which I foresee might be your more answer to this question as well. But maybe we start from the generative AI, and then we can cover this question as well. So can you give us some more in-depth or what we are doing in this generative AI area in Ericsson today?
I mean, of course, like you cannot run a discussion today on AI without people bringing up the generative AI and ChatGPT-like of thing into the telco domain. But large language models as a technology is not really very new. I mean, like this is something that where we have, as an Ericsson, doing significant research for the past years. And we actually have our own large language models that have been trained on billions of data points coming from telco domain and the telco networks. Think about, trouble tickets, think about, traces, think about performance data, configuration data, et cetera, et cetera. So generative AI, the promise that brings to us as one of the prominent AI technologies, we see it in two different main applications, I would say. The first one is the interaction between human and systems and automated systems. So if you think about operation support systems, if you think about systems like cognitive software or systems that are dependent in some sort of a UX or a GUI interaction, we see generative AI as one of the most promising technologies to make this kind of interaction simpler. There is nothing simpler than communication in natural language, right? So what do you think that if you are able to type a question to the network, let's put it in this way, and then you get an answer to this in a natural language, and then you are able to say like, okay, hey, I would like to do a plot of X and Y parameters versus each other, and then you get this very instantaneously. So this kind of promise that the large language models in tremendous capability to transform human language into, I would say, data points and also instructions that we can use and implement. This is a tremendous part where generative AI is going to be very important for telco networks, is how we really interact with the telco infrastructure and the telco systems managing this infrastructure. The second part is where we get more deeper insight that covers a lot of relationship that we don't know, even in the current deep neural network implementation that we have. Remember, like large language models, why we call them large? Because they have been trained on billions of data points, actually sometimes even trillions of data points, it depends. Then the ability for you to make the connection, or the ability of the algorithm to make the connection between the different insights coming from different data points and different text corps is tremendous. So this actually opens a new area of how we can move into a true intent-based operation of the network, where again, you would like not just to inquire about the status, it's actually to give an instruction. I would like to see a performance improvement of, I don't know, 10% in the downlink throughput. What should I do? You put this question to the generative AI agent, and then you get an answer. Here you go. You should do this parameter change on this XYZ cells. So this is the kind of where we see the application of Gen AI as one of the prominent AI applications, or say AI technologies. But of course, in addition to generative AI, we have different parts related to intent-based networks. We have quantum, artificial intelligence, et cetera, et cetera. These are all different technologies where we're actively working to make it available to our operators.
Yeah, many future-looking and a bit ahead in this AI technology area, right?
Yes, correct.
And with that, I would like to open up for the Q&A, actually. So thank you very much for answering that question. And I think we have a next question to Claudia. And it's Amar, interested in hearing about AI adoption challenges and success stories. You have a few comments on that, Claudia?
Yes. So, I mean, when it comes to AI adoption, what we see clearly is that 60% of the challenges occur on the change management processes. And as Ibrahim was explaining, very much on the trust of the engineers, but also a lot of challenges occur just by getting the data into one common place and data lake, right? So those are the areas that we see the frontrunner customers have been more successful than the rest of the market, right? Because they took very early steps on it, but also because they put this at the heart of their priorities, right? So it is a priority to have our common data lake with all the clean data ready there for us to use. It is a priority to create cross-functional teams. It is a priority to work around this, and it is a priority to transform the processes so that we embrace this. Another thing that is quite interesting is how they are taking steps towards something, right? So imagine you want to have this, zero touch, completely autonomous, predictive and preventive system. You can't run before you can walk, right? So you need to put all the data there. You need to start by having strong diagnostics capabilities. Then you start having recommendations. Then you evaluate, do I trust these recommendations? Okay, do they work? Yes. Then you implement closed loop automatically. And then once you have all that set up across a certain process, then you start expanding. And then you see, okay, can we explore some predictiveness? Is it realistic for this type of use case and insight I want to create, and so on? So it's about understanding that this is a marathon, it's not a sprint. Having the right strategy, the right priorities, the right budget allocations, and taking it as a long-term journey rather than, trying to materialize something very, very advanced and then just getting frustrated and saying, this doesn't really have any value, so then we step away from it. So those are the recipes for success. If we can summarize on 3 things. Address it as a whole change, not only the technology, okay, the people, the skills, the organizations, and especially the end-to-end processes. Put a strong priority on all the data aspects of it and consolidating this into one place. And then also make sure that the AI is something that the engineers can trust, because they need to understand it, and that goes through skills, but that also goes through implementing explainable AI, like Ibrahim was explaining, so that the people can, expert engineers that are not dumb can really understand how this actually, helps them work smarter rather than hard. So those are some of our learnings.
Thank you, Claudia. And I also really like the reference of it's not a sprint, it's a marathon. So very good. So we have a quick question now, Ibrahim, to you from Abdul. I'm interested in understanding if Ericsson is leveraging AI to streamline and enhance the network within the network rollout and engineering domain, as opposite to just focusing on the network operations domain. Could you share any initiatives or work being done in this area?
Yeah, so in this area, there is an active work and current capabilities as well when it comes to either that we embed in the product itself, like Ericsson radio system, and Ericsson management systems, and also the way and the services that we provide. So coming to the digital twin example for like that we were discussing for network optimization, we also have a digital twin as well that helps our customers to better design their network, better prepare their inventory, and better actually run their rollout projects as well. So we already have existing capabilities as of today, and we are working to increasing those more in the engineering part and the rollout as well.
Thank you. That was a quick answer. Very good. Yes, so closing this session now. So with that, I want to mention 3 things. So first of all, visit our cognitive technology page where you can read about our existing offers and also what is to come, such as the digital twin paper we talked about. And also we are looking forward to see you again after summer, because then we will have this session that we hinted about before, where we deep dive into a case study on the benefits of this AI transformation. So very interesting. So stay tuned for that. And with that, I would like to thank you, Claudia and Ibrahim, for joining me to talk about this very important topic. And also thank you to you online for joining in and asking such great questions. And have a great rest of the day. And we are looking forward to see you after summer.
Thank you.
Thank you.